Okay, now that we had gone through the folder structure, let me start with the CAD drawings. So first we check the feasibility. So the current one, GD&T we open, right? And here is the GD&T. So it's a 2D drawing, and it has mentioned which will be the stamping direction, right? And okay, so the stamping direction is this way, and also it has, now what we need to see, the data may. So the data may are these four: A1, A2, A3, A4. These 4 points are having diameter 18. We have to make sure that the part when we check in the gauge fixture must not have net pad size bigger or smaller than this, right? Then we have datum B and C. So now we know that when we check the part, it has to be checked against datum A, and datum B is this whole round hole, a 4 point check it will be. So the point pin will have 4 points, or throughout it will be like 12.5 plus minus 0.05. You see there is no positional tolerance given because it's a datum. Datum C is 2 point only. Even if it's a hole, a round hole, it just uses 2 point, 12.5 plus minus 0.05 datum C. And the other diameter, 12.5, it has a tolerance over there. And then this now we have to see the trim line. So after the datum B and C, when the part is clamped on datum A, B and C, right, clamped on datum A and located on B and C, then we have to check the part. So for example, this trim line, it has to have plus minus 1.5 millimeter tolerance with respect to ABC. B and C will have max condition, and this one here, positional tolerance is plus minus 0.5, right? And now we go to these two flanges. These two flanges has plus minus 0.7. It's a surface tolerance over here, right? And then these oblong hole size is 8.5 into 12.5 with the positional tolerance as mentioned plus minus 0.5, right? And these are those two are actually datum E, D and D, those as you can see over here, right? Now we see this side, this surface has plus minus 0.7 tolerance again, all these three small flanges. And over here, as you can see, 44 is the distance between these two holes. Okay, let me turn it, I'm rotating it once more. Yes. So we can see these four small holes which are dia 5.5, size tolerance is plus minus 0.1, and positional tolerance is plus minus 0.5, right? All these four holes. Okay, so now we check the general tolerance on surface plus minus 1 and on trim line plus minus 1.25. Material is it's a Ford part, and the material is as per Ford spec M1A365, right? And thickness is 1.6 millimeter. Anything else? Yeah, that's all part number. So this is the 2D. Now we open the 3D. Now we are going to open the 3D here, and okay, here it is. We are going to open the 2D now. So this is the latest 3D file for this part. It will take some time. Okay, so this is open. As you can see, so this is the latest 3D data of this part based upon what we have designed the strip layout, design the dies, build the dies. I'll tell you that this has some changes. This has some changes with respect to the first data which we had gotten from the customer. So that was not feasible. Like I told you that we do some feasibility study. I'll show you how it used to look the very first part and what changes we did here. So I'm opening the very first part here. So that is what we had received from customer, and okay, it's getting open now. Okay, so this was the first part what we had received. Now you can see just in this area we have changed it. The radius was very sharp over there, and okay, let me import and do a quick overlay for you with respect to the latest data. It's getting imported. Okay, you can see there is a radius difference, you can see there is a trimline difference. So let me do render with the edges, and you can see, so we have provided that notch. Without that it was not possible to form it. I'll show you when we discuss the simulation. Alright, so apart from that, nowhere else we had any problem. So only that area we had problem. Everywhere else we were good. So that area we did change, right? And after like couple iterations, our changes were approved by customer. They accepted it, and based upon the latest data, this OK data, which is green data, we made the strip layout, we made the die design, and we built the part. Everything was done with respect to this data. Okay.